Hi everyone, this video is on mixed exercise 13 question 17. So we have this diagram which shows the line y is equal to x minus 1 meeting the curved equation y is equal to x minus 1 times x minus 5. And in part A, we want to write down the coordinates of A and B and also find the coordinates of C. Okay, so the coordinates of A and B can be found by just solving this equation. So x minus 1 times x minus 5 is equal to 0, and that gives us two values. So either x is 1 or is equal to 5. So the coordinates of A are 1, 0, and for B we have 5, 0. So here is 1, here is 5. Okay, now we also want to find the coordinates of C. So C is the point of intersection of the curve and the line. So to find the coordinates of C, we need to solve an equation, and we just need to set the equation of the line equal to the equation of the curve. So we have x minus 1, which is the equation of the line, is equal to the equation of the curve. And now we just need to solve this quadratic to find the solutions. So we can here write x minus 1 for now and expand the right hand side. So we get x squared minus 6x plus 5. Let's now rearrange the equation. So we have x squared minus 7x plus 6 is equal to 0. And we have x minus 1 times x minus 6 is equal to 0. So we get two solutions. X is equal to 1 or x is equal to 6. Now looking at the graph, obviously C is 6. So C has x coordinate 6, and to find its y coordinate, we just substitute 6 into, let's say, equation of the line, and that's equal to 5. So we have coordinates of C now. Okay, so that's the answer to part A. Now in part B, we want to find the area of the shaded region bounded by the line, the curve, and the x-axis. Okay, so to find this area, we can use a simple trick. And that trick is that if we draw a perpendicular line from point C to the x-axis, as you can see, a triangle is going to be formed. That triangle is the triangle AC, and let's call it here D. So maybe it's better to draw a better perpendicular line. So we roughly have something like this. And let's say here is point D, which has x coordinate of 6, obviously, because that's just perpendicular. So that's the same x coordinate as point C. Now, so if we have this triangle, then that allows us to answer part B, because if we find the area of the triangle, that gives us the total area of this region plus this white region. But we want to exclude the area of the white region. So we just take away the area under the curve bounded by the curve and the x-axis, because that gives us the area of the white region. So we can take that away from the total area of the triangle, and that the remaining area is going to be the area of the shaded region. So in this case, what we have is that the area of the shaded region is equal to, so we have the area of the triangle is A, let's say here is D, ADC, triangle ADC, minus this integral, which is the area under the curve. So the limits are 6 and 5, and the equation of the curve is x minus 1 times x minus 5 dx. And yes, so solving this will give us the area of the shaded region. So first, the area of the triangle. So the base is just 6 minus 1, which is 5, and then the height is also 5. So we have a half times 5 times 5, and then minus this integral, which is x squared minus 6x plus 5 dx. Okay, so area is equal to 25 over 2 minus, let's integrate. So we have 1 over 3x cubed minus 3x squared plus 5x, and then the limits are 6 and 5. So we just need to substitute the limits. So we substitute 6 and then minus 5 substituted. So once we do that, we get minus, I mean, we have this minus here, but the value that we'll get is 7/3. And therefore the area is equal to 61/6.